Electrostatics.
Now we want to see the second combination of capacitors, that is the in parallel combination. Parallel combination means here we want to take the three capacitors, right? These capacitors are parallel to each other. Parallel to each other means here the first plate of each capacitor is connected to the common point. Suppose this the common point is A. Similarly, the second plate of each capacitor which is connected to the common point, suppose that common point is there B, right? Then such combination called as the parallel combination. And again to the point A we give the positive potential, and the point B which is connected to the earth, right? So this will be the negative plate, this will be the positive plate, this will be the battery. Then it means that this will be the first capacitor, their capacitance is C1, this will be the second capacitor, their capacitance is C2, and now this will be the third one, that is C3, right? Here what happened, the potential drop, here this battery gives the potential, suppose that potential is there V, then in this case the potential drop across each capacitors are same because of all the capacitors which are connected in parallel, and in parallel combination the potential drop is same. If their potential drop is same but the current flowing through each capacitors are different, it means that the number of charges deposited on each plates of capacitors are different. Suppose that if we consider this to be the first one, then on the first plate of the first capacitor their number of charges deposited is the Q1, right? And automatically here what you get there, minus Q1. Now this will be the input charges. On the second plate what you get there, their number of charges deposited Q2, and now this will be the minus Q2. Here what you get there, plus Q3, and now this will be the minus Q3. It means that on each capacitor the number of charges are different because of their capacities are different, right? Such combination is nothing but the parallel combination. Then in parallel combination what happen here, suppose here through this point up to this point the current is I, right? And after that point A, that current is divided into the three parts, I1, so this will be the I2, this will be the I3. Here the current is divided, it means that charges which is divided. Here suppose if we consider due to the current I, here total number of charges are Q. Due to the current I1 their charge is Q1, due to the current I2 their number of charges are Q2, and due to the I3 their number of charges are Q3. So here what we get there, total number of charge Q which is equal to the Q1 plus Q2 plus Q3. It means that here the charges are divided in a three-way, that is the on the three plates or three capacitors. So total charge is Q. Now if we consider this will be the equation number 1, right? So this will be the equation number 1. Then we want to substitute the value of Q, Q1, Q2, Q3, right? So here Q which is equal to the, we know the equation of capacitance, what we get there, C which is equal to the Q upon V, then Q which is equal to what we get there, CV. So we want to use this formula, right? Here Q is the total charge, that is effective charge. Then here we want to take the effective capacitance in parallel and their potential is V. This is about the effective. Now for the first capacitor, this the value is Q1 which is equal to the C1 into the V. Now for the second one, Q2 which is equal to the C2 into the V, and for third capacitor Q3 which is equal to the C3 into the V. Now suppose this will be the equation number 2. Now we want to substitute these individual values in this equation. So what we get there? Here the value of Q is CPV. Here CP represents the effective capacitance in parallel combination. So CPV, which is equal to the, here the value of Q1 is C1V plus second one is there C2V plus third one is there C3V. Now here from the RHS side we take the V is common, so what we get there? CPV, which is equal to the C1 plus C2 plus C3 into the V. What we get there? VV get cancelled. So CP, which is equal to the C1 plus C2 plus C3. Right? So this will be the equation of effective capacitance in parallel combination. Here we want to see the effect of parallel combination. Suppose here if you take the capacity of the first one is 2 microfarad, second one is also 2 microfarad and third one is also 2 microfarad, then the value of effective capacitance is what you get there. What you get there? Example, C1 which is equal to the 2, C1 equal to the 2, then C2 which is also the 2 microfarad, C3 which is also the 2 microfarad, then effective capacitance CP which is equal to what you get there? 2 plus 2 plus 2, that is the 6 microfarad. It means that due to the parallel combination, the effective capacitance of that systems are increases. Right? So this will be the effect of parallel combination. Right? See this one.